Hello and welcome to Infanor's Motion Made Easy series. In this episode we will go over the load torque calculator located in the Motion Toolkit application. This assumes that you know your application's motion profile and have calculated your reflected load inertia. Start by opening the Infranor Motion Toolkit on your mobile device. Continue to the toolkit and open the load torque calculator window. Next, the profile type will be chosen and depends on whether your application is distance or velocity dependent. Both profiles will give the same result but are just set up with different objectives in mind. For this tutorial, I will use the velocity profile. The velocity profile is broken up into 5 sections with the corresponding results area below. The velocity section is the max velocity the motor will see during the application. I will use 4,000 RPM. The acceleration time is the time it will take for the motor to reach the max application velocity specified. I will use 0.6 seconds. The time at velocity is the time that the motor will stay at constant max velocity. I will use 2 seconds. The deceleration time is the time it takes for the motor to go from max velocity specified to 0 RPM. I will use 1 second. The dwell time is the time that the motor remains at 0 velocity before starting the next cycle. By increasing this time, the RMS torque calculation can be decreased for the cycle. I will use 5 seconds. We can then press calculate to get our profile results, which are stored for the torque calculation. Continue to the torque calculation by pressing next. Here, there are 3 additional areas to fill in if applicable. The reflected inertia area was calculated in the inertia calculator tutorial and was 0.00455 kilograms meters squared. The constant torque at the motor shaft section is used for vertical applications or in some preload situations where there is torque applied to the shaft even at 0 velocity. I will keep this value as 0 Newton meters. The last section is for any frictional torque that may be due to contacting surfaces while the motor is moving. I will also keep this at 0 Newton meters. We can then press calculate to get our peak and continuous torque requirements for the application. We will use these values for the motor/drive selection tutorial. By using the contact tab at the bottom, please feel free to contact us for more information. You can also find more information about our advanced slotless FP design on our USA and corporate websites. That concludes this episode. Thank you for watching.